Welcome to these gentle, soothing stories for sleep. Tonight, we begin a journey into the great canopy above, an exploration of the sky, that endless and beautiful veil that has cradled our dreams since the dawn of humanity. We will drift through its colors, wander among its lights, and find in its vastness a quiet place for our minds to rest. Before we begin our journey, I would love to know where you are listening from tonight, what small piece of the sky you can see from your window. Please feel welcome to leave a comment below. And if these stories bring you comfort, please support this channel with a like and a subscription. Your kindness makes these journeys possible. Thank you so much. And now, find a comfortable position. Let your body feel heavy, and allow your breath to slow as we turn our gaze upward and begin. The simple act of looking up is perhaps the most universal of all human experiences. A silent gesture shared across continents and millennia. A quiet question asked of the immense and silent canvas above. We see a dome of blue, so familiar and so constant that we often forget to consider it not as an absence, not as a simple void between us and the sun, but as a substance, a place, a vast and vibrant ocean of air. Imagine for a moment that you are not at the bottom of the sky, but at the bottom of an ocean of an impossible size, pressing down upon the world with a gentle, life-giving weight. The air that moves against your skin as a soft breeze is not emptiness in motion, but a current in this invisible sea, a river of nitrogen and oxygen flowing around the curve of the earth. This atmospheric ocean is composed almost entirely of two elements, two gases that swirl around us in every moment. About 78% is nitrogen, a quiet, stable, and unassuming element that fills the spaces, providing the substance and body of the air we move through. And about 21% is oxygen, the spark of life, the element that fuels the fire in our cells with every breath we take. These two gases, along with a few other trace elements, form the transparent medium of our world, a sea so clear that we can see the stars through its depths. And yet, it is not perfectly transparent. It has a color, a breathtaking and ephemeral blue that is not a dye or a pigment, but an event, a continuous performance of light and matter. The light from our sun, a star more than 90 million miles away, travels through the vacuum of space as pure, white light. But this whiteness is a beautiful illusion, for woven within it are all the colors of the rainbow, from the long, gentle waves of red and orange to the short, energetic waves of blue and violet. When this stream of multicolored light finally reaches our world and plunges into our atmospheric ocean, it begins to interact with the trillions upon trillions of tiny nitrogen and oxygen molecules suspended within it. Most of the longer wavelengths, the reds and yellows, are like large, smooth stones, slipping through the currents of this ocean, mostly undisturbed, continuing their journey directly to our eyes. But the shorter wavelengths, the blues and the violets, behave differently. They are so small and energetic that they are perfectly sized to be caught and scattered by the tiny molecules of the air. You might imagine it like striking a bell. A very large bell produces a deep, low-frequency sound that travels a long way. A tiny bell, however, produces a high, sharp sound that seems to shimmer and radiate in every direction at once. In this same way, the tiny air molecules ring with the blue light, absorbing it for a fleeting instant, and then flinging it out again in a new, random direction. This process, known as Rayleigh scattering, happens over and over and over again, billions of times in the space of a single breath, as the blue portion of the sunlight is bounced from molecule to molecule, filling the entire sky from every direction. So when you look up at the daytime sky, the blue you are seeing is not the color of the atmosphere itself, but rather the scattered light of our sun, a luminous echo of a star's fire, redirected and presented to you by the very air you breathe. It is the color of a connection, a relationship between a distant star and a living planet. And this ocean of air has weight. From the ground to the edge of space, the column of air above you presses down with a force equivalent to a thick, heavy blanket. We call it atmospheric pressure, and at sea level, it is a constant 14.7 pounds on every square inch of our bodies. We do not feel this immense weight because we have always lived within it. Our bodies are built to exist in this gentle pressure, which pushes on us equally from all sides, holding us in a constant, unnoticed embrace. This pressure is what allows water to remain liquid on the surface of our planet, what allows us to breathe, and what holds our world together in a delicate, life-sustaining balance. It is the weight of our protection, the substance of our shield. So as you settle into the quiet of this moment, feel the air around you, not as emptiness, but as a presence. A deep and ancient sea of soft blue light, a substance as real and as vital as the water in the oceans, a gentle weight that connects you to the very fabric of our living world. This is our first veil, the most familiar layer of the sky, a luminous breath that fills the space between the soil and the stars. And in this vast blue ocean of air, great, silent ships begin to form, drifting on invisible currents, their forms ever-changing, their substance a paradox of immense weight and impossible lightness. We call them clouds, and they are perhaps the most poetic and expressive feature of the sky, the visible breath of the planet made manifest. A cloud's life begins not in the sky, but on the surface of the earth, as a silent and invisible ascent. The warmth of the sun gently touches the surface of a lake, an ocean, a river, or even a single leaf glistening with morning dew, and coaxes individual molecules of water to let go of their liquid bonds and rise into the air as vapor. This invisible migration, this evaporation, carries the essence of the Earth's water high into the troposphere, the lowest and most dynamic layer of our atmospheric ocean. As this warm, moist air rises, it begins to cool, and a magical transformation occurs. The water molecules, once energetic and solitary, begin to slow down, and they seek each other out, looking for a place to gather. They cannot, however, simply form a droplet out of nothing. They need a nucleus, a tiny physical speck to cling to. These nucleation sites are everywhere, the microscopic dust of the world, a grain of pollen from a distant forest, a crystal of salt swept up from a breaking wave, a particle of ash from a faraway fire. Upon these tiny invisible anchors, the water vapor begins to condense, molecule by molecule, trillion by trillion, until a community is formed, a visible droplet of liquid water or a delicate crystal of ice, so small and so light that it can remain suspended in the air. A cloud is not a single thing, but a floating city of these tiny droplets, a visible manifestation of a great and silent gathering. These celestial gatherings take on a beautiful variety of forms, a language of shapes that tells the story of the air in which they are born. High in the coldest reaches of the troposphere, where the air is thin and stretched, we see the cirrus clouds, their name meaning a curl or a wisp of hair. They are made not of water droplets, but of delicate ice crystals, blown by the fierce high-altitude winds into long, feathery streaks, like a painter's brushstroke across the deep blue canvas. They are the most ethereal of clouds, a frozen whisper hinting at the coldness of the upper air. Lower down, we often find the stratus clouds, their name meaning to stretch or to layer. These are the clouds that form in stable, calm conditions, creating vast, uniform sheets of grey that can cover the entire sky like a soft blanket, muting the sunlight and creating a sense of quiet, enclosed peace. And then there are the most iconic and dramatic of all, the cumulus clouds, their name meaning a heap or a pile. These are the clouds of childhood drawings, the great, puffy, cotton-like castles that drift through a summer's day. They are born from strong, rising columns of warm air called thermals, and their flat bottoms mark the exact altitude where the rising water vapor began to condense into visible droplets. They are monuments of vertical energy, constantly growing and changing, their bright white tops a testament to the powerful sunlight they reflect. The greatest paradox of a cloud is the relationship between its appearance and its reality. It drifts with such effortless grace that we think of it as weightless, as mere smoke or vapor. But this is a profound illusion. A single, medium-sized cumulus cloud, a cheerful puffball that might wander over your home on a sunny afternoon, can hold within its floating form over 100 tons of water. Some larger storm clouds can carry the weight of hundreds of thousands of tons. An entire herd of elephants made of water, suspended miles above the ground. The secret to this impossible levitation lies in its distribution. This immense weight is not in a single place, but is divided among trillions upon trillions of microscopic droplets, each one so small and light that the gentle upward pressure of rising air can keep it aloft, or at the very least, slow its fall to a near imperceptible drift. A cloud is a masterpiece of balance, a constant, delicate dance between the downward pull of gravity and the upward push of atmospheric energy. It is a state of being, not a static object, a place where water is held in a state of suspense before it is ready to be released back to the earth as rain. And in their bright whiteness, clouds perform one last, crucial service. They are the Earth's great parasols. Their surfaces are so reflective that they bounce a significant portion of incoming sunlight directly back into space, a phenomenon known as the albedo effect. This simple act of reflection helps to shield the planet from overheating, playing a vital role in the gentle self-regulation of our world's climate. They are not just beautiful, transient sculptures, but active and essential components of the living system of our world. They are the sky's changing face, a constant reminder that even in the clearest blue, there is substance, there is motion, and there is the promise of a gentle, life-giving return to the earth below. The sky's changing face, sculpted from these cities of vapor, is painted not only by their forms, but by the ever-shifting angle of the light that illuminates them. As the day begins its long, slow exhalation towards evening, the earth itself begins to turn away from the sun, and the character of the light that bathes our world undergoes a profound transformation. The crisp, direct blue of midday softens, and the journey of the sunlight into our atmospheric ocean becomes a longer, more oblique passage. When the sun is high overhead, its rays take the most direct path through the air, a relatively short plunge that scatters the blue light and allows the rest to pass through. But as the sun descends towards the horizon, its light must skim the curve of the earth, travelling through hundreds of miles more of dense air, a journey through a far thicker and more turbulent part of our gaseous sea. On this extended voyage, the blue and violet light, so beautifully scattered during the day, is now scattered so completely and so many times that it is effectively filtered out, cast away into the upper atmosphere, never reaching our eyes at all. The gentle, long wavelengths of light, the yellows, the oranges, and the reds, which pass so easily through the air, are the ones that endure this long journey. They are the marathon runners of the spectrum, and as the sun sinks lower, they are the only colours left in the race, the only ones that can finally break through the thick air to paint the clouds and the horizon. This phenomenon, a different kind of scattering known as Mie scattering, is what sets the sky on fire. It is an echo of the same physics that colours the day, but performed under different conditions, creating a dramatically different result. And this celestial fire is made all the more brilliant by the very substance of the air itself, by the dust and the haze that hang suspended within it. Every tiny particle of dust thrown up by the wind, every minute grain of pollen from the trees, every crystal of sea salt lifted from the waves, becomes a tiny canvas for the sunset. These particles, which we call aerosols, are much larger than the individual molecules of nitrogen and oxygen, and they are perfectly suited to scatter the long red wavelengths of light in all directions, amplifying the sunset's glow and creating the breathtaking displays of crimson and gold that signal the day's end. A truly spectacular sunset is therefore a kind of atmospheric bulletin, a report on the air's condition. The brilliant reds can speak of dust carried on the wind from a desert thousands of miles away, or of smoke and ash from a distant forest fire, or even a volcanic eruption, whose particles can linger in the stratosphere for years, painting sunsets for the entire globe. The colours are a story of the world's breath, of its dust and its fire, told in the final moments of its light. As this spectacle unfolds, you are witnessing your specific location on the planet moving across a great and invisible boundary line, the Terminator. This is not a sharp edge, but a soft, diffuse zone of twilight that separates the daylit hemisphere of the Earth from the hemisphere of night. It is the edge of the planet's own shadow, a vast wave of darkness that is constantly sweeping across the surface of the globe at the speed of its rotation. At the equator, this line moves at over 1,000 miles per hour, a silent, steady rush into darkness. For those of us living farther from the equator, its passage is slower, more gentle, allowing for the long, contemplative twilight that we cherish. As you watch the sunset, you are, in a very real sense, watching the world turn, feeling the great, silent machinery of the solar system, carrying you away from the sun's light and into the cool peace of the night. On the rarest of occasions, just as the last sliver of the sun's disk is about to vanish below the horizon, a fleeting emerald light can appear for a second or two, a phenomenon known as the green flash. It is a final, beautiful trick of the atmosphere, which at that low angle acts like a weak prism, splitting the sunlight into its constituent colors and, for a brief moment, allowing the green light to be the very last color we see. It is a final, quiet jewel offered by the day before it gives way completely to the deep indigos and purples of the falling night, a moment of profound and gentle transition as the world holds its breath and prepares for the stars. In the profound stillness of that deep twilight, after the last blush of crimson has faded from the western sky, a deep and silent peace settles upon the world. The air grows cool, the colors of the landscape melt into soft shades of grey, and the dome of the sky darkens to a near black. It is in this hushed interval, this pause between the worlds of day and night, that the next act of the sky begins. A single point of light appears, sharp and brilliant against the velvet darkness, the first star of the evening. This gradual descent into night is a process with its own gentle structure, a series of thresholds that astronomers have named. The first is civil twilight, the period just after sunset, when there is still enough scattered light in the sky to see clearly, to distinguish the shapes and colors of the world around you. This is followed by nautical twilight, a deeper state of dusk, where the horizon is still visible as a distinct line against the sky. But the brightest stars have now emerged, a crucial time for sailors of old who could navigate by taking measurements between the stars and the sea. And finally, the world settles into astronomical twilight, the last stage before true night, where the sky is so dark that only the faintest, most diffuse glow of the departed sun remains, a subtle light pollution that must fade completely before astronomers can begin to study the faintest and most distant objects in the universe. That first brilliant point of light to appear is very often not a star at all, but a planet. Most commonly, it is the planet Venus, our celestial neighbor, earning it the ancient names of the evening star or the morning star. It shines with a radiance that far outstrips any true star, and it does so for two simple reasons. It is relatively close to us, and its surface is shrouded in a thick, continuous layer of highly reflective clouds, which act like a brilliant mirror for the sun's light. You can often distinguish the silent wanderers of our solar system, the planets, from the distant, fiery suns we call stars. By a simple observation, stars appear to twinkle, while planets typically shine with a steady, unwavering light. This twinkling is not a property of the star itself, but a final illusion created by our own atmosphere. A star is so unimaginably far away that its light arrives at Earth as a single, infinitesimally small point. As this pinpoint of light passes through the turbulent layers of our atmosphere, with its shifting temperatures and densities, the light is bent and refracted 1,000 times a second, causing it to dance and shimmer in our eyes. A planet, being so much closer, appears to us not as a point but as a tiny, solid disk. The light from this disk also gets refracted by the atmosphere, but the twinkling from one side of the disk is averaged out by the twinkling from the other, cancelling out the effect and resulting in a calm, steady glow. To gaze upon that first light, whether it is the reflected glow of Venus or the ancient fire of a distant star like Sirius, is to engage in an act of time travel. Light, though it is the fastest thing in the universe, still has a finite speed, moving at a constant 186,000 miles per second. This speed, while immense, means that light still takes time to cross the vast distances of space. The light from Venus, when it is visible in our evening sky, has been travelling for several minutes to reach your eyes. You are not seeing the planet as it is right now, but as it was a few minutes in the past. For the stars, this temporal gap is vastly greater. The light from Proxima Centauri, the nearest star to our sun, takes more than 4 years to cross the void and arrive at our planet. The light from other familiar stars in our sky has been traveling for decades, centuries, even millennia. You are seeing a ghost of light, an image of a star as it was when great empires rose and fell on Earth, its ancient photons completing their long journey in the quiet moment you happen to look up. To measure these colossal distances, we use the journey of light itself as a yardstick. A light year is not a measure of time, but the staggering distance that light can travel in 1 year. Nearly 6 trillion miles. It is a unit that speaks to the true scale of the veil above, a space so vast and so deep that even its most brilliant lights are just echoes from a time long since past, arriving now as a gentle whisper in the profound silence of the night. That ancient light, arriving from distant suns across chasms of space and time, finds itself sharing the night sky with a much closer and more intimate light, a soft, silvery glow that feels less like a distant whisper and more like a silent companion. This is the light of the moon, an object so familiar and so deeply woven into our poetry, our myths, and the rhythm of our lives, that we can sometimes forget the astonishing story of its creation and the profound, silent work it performs in our sky. The moon is not a captured wanderer from some other part of the solar system. It is a child of the Earth, born from a moment of unimaginable violence some 4.5 billion years ago. In the chaotic youth of our solar system, the early Earth, still a molten sphere of magma and rock, collided with another nascent planet, a body roughly the size of Mars that astronomers have named Theia. This cataclysmic impact, a blow of almost unimaginable force, vaporized the intruder and blasted a tremendous portion of the Earth's own mantle into orbit. For a time, our world was surrounded by a glowing ring of molten rock and debris, a fiery halo in the primordial darkness. Over thousands of years, the slow, patient force of gravity began to pull this material together, gathering the fragments, coalescing the dust and magma into a single, smaller sphere that cooled and solidified to become the moon we know today. So when you gaze upon its calm, pockmarked face, you are looking at a piece of our own world, remade by fire and collision, a constant reminder that from the most violent of beginnings, a quiet and lasting beauty can emerge. This shared origin story has bound the Earth and Moon in a deep gravitational dance ever since. In its youth, the Moon spun much more rapidly and was much closer to the Earth than it is today. The immense gravitational pull of our planet tugged on the Moon's still molten form, creating a tidal bulge, a slight elongation of its spherical shape. This bulge acted like a brake, and over millions of years, the Earth's gravity slowed the Moon's rotation until it reached a perfect, stable equilibrium, a state we call tidal locking. This is why the Moon now rotates on its axis in the exact same amount of time it takes to orbit the Earth, and it is the reason we only ever see one side of it. The familiar face of the man in the Moon is a permanent feature of our sky, a face turned always toward us in a gesture of gravitational fidelity, while its far side remained a complete mystery to humanity until our first space probes journeyed there. Its changing shape in our sky, the beautiful and predictable cycle of its phases, is a simple illusion of perspective. The Moon does not grow or shrink. It is always a sphere, with one half illuminated by the sun. As it makes its month-long journey around our planet, we on Earth simply see different angles of that sunlit hemisphere, from a thin, glowing sliver of the new moon to the full, brilliant circle of the full moon, and back again to darkness. This silent, steady cycle is the clockwork of the cosmos made visible, a reliable and gentle rhythm that has governed the nights of every creature that has ever lived on this planet. Perhaps the moon's greatest gift to us, however, is one we can neither see nor feel directly. It is the gift of stability. The Earth, like a spinning top, has a natural wobble in its axis of rotation. Without the steadying influence of a large moon, this wobble would be much more chaotic and extreme. Over vast stretches of geological time, our planet's tilt could swing wildly, leading to catastrophic shifts in climate, where the poles might melt and the equator might freeze. But the constant, gentle gravitational pull of our nearby moon acts like a stabilizing hand, an anchor that holds the Earth's axial tilt within a narrow, stable range. It is this stability that has given our planet its predictable seasons, the reliable cycle of spring, summer, autumn, and winter that has allowed complex life to evolve, to adapt, and to flourish. The moon, our silent mirror in the night, is therefore not just a decorative ornament or a poetic muse, but a fundamental architect of our world's habitability. It is a guardian, a silent partner in the long story of life, its serene and constant presence, a calming influence that touches everything from the rhythm of the ocean's tides to the very possibility of a temperate and life-sustaining world. From that silent, companionable world of the moon, imagine for a moment looking back at the Earth. You would see our planet not as a solid ground beneath a vast sky, but as a swirling, blue and white marble suspended in the blackness of space. And the sky, our great atmospheric ocean, would appear as it truly is. A breathtakingly thin, fragile, and luminous blue line, a delicate membrane of air separating the living world from the infinite void. It is this membrane, this ladder of the sky, that we will now ascend, journeying upward from the ground through the distinct and invisible layers that make up our world's gentle shield. Our journey begins in the layer we know best, the one in which we live and breathe, the troposphere. This is the first and densest rung of the atmospheric ladder, stretching from the surface of the Earth up to about 7 miles high. The troposphere is the atmosphere's living room. It contains over 75% of the atmosphere's mass and nearly all of its water vapor. It is the realm of weather, the turbulent and dynamic stage for the clouds we see, the winds we feel, and the rains that nourish the land. Its name comes from a Greek word meaning to turn or to change, and it is in a constant state of motion, with warm air rising from the ground and cool air sinking from above, a ceaseless churning that creates the rich and complex conditions necessary for life. It is the warm, chaotic, and life-giving skin of our planet. As we continue our ascent, climbing higher than the tallest mountains and the highest flying birds, we pass through an invisible boundary called the tropopause and enter into the second great layer of the sky, the stratosphere. Here, the turbulence of the world below fades away into a profound and layered calm. The air is much thinner, and the chaotic churning of the troposphere is replaced by stable, stratified layers of air, which is what gives this region its name. Commercial airplanes prefer to cruise in the lower stratosphere to take advantage of this smooth, predictable air. But the most vital feature of this calm realm is a special concentration of molecules that form an invisible, life-saving shield. The ozone layer. Ozone is a special form of oxygen, made of 3 oxygen atoms bonded together instead of the usual 2. This O3 molecule has the unique ability to absorb the most energetic and harmful forms of ultraviolet radiation from the sun. The ozone layer acts as a planetary sunscreen, a silent and tireless guardian that filters out this dangerous radiation before it can reach the surface, protecting all living things, including us, from harm. This serene, cold layer is a testament to how the most vital forms of protection are often the most quiet and unseen. Rising still higher, above 99.9% of the atmosphere's mass, we enter the mesosphere. The sky here is no longer blue, but a deep, star-filled black, as the air has become far too thin to scatter sunlight. The mesosphere is an incredibly cold place, the coldest region of the entire Earth system. But it is also a fiery curtain of protection. This is the layer where the vast majority of meteors, the small fragments of rock and dust that constantly bombard our planet from space, meet their end. Traveling at speeds of tens of thousands of miles per hour, these tiny cosmic bullets slam into the sparse molecules of the mesosphere, and the resulting friction generates an incredible amount of heat, causing them to glow brightly and vaporize into nothing more than a streak of light, a shooting star. Every time you witness one of these fleeting flashes, you are seeing the mesosphere at work, silently incinerating cosmic debris in a final, beautiful act of planetary defense. Finally, we reach the vast upper deck of the atmosphere, the thermosphere. This enormous layer begins at around 50 miles up and stretches for hundreds of miles, eventually fading into the vacuum of space. The air here is so extraordinarily thin that individual molecules can be miles apart from one another. This leads to a strange paradox of temperature. The few particles that exist in the thermosphere are superheated by the sun's direct energy, reaching temperatures of thousands of degrees. Yet, it would feel profoundly cold to us, because there are simply not enough particles to transfer that heat energy to any object. It is in this vast, near-empty realm that the International Space Station orbits the Earth, and it is here that the beautiful, shimmering curtains of the Aurora Borealis and Australis perform their silent dance. We have climbed the ladder of the sky, from the dense, breathing air of our home, through layers of calm and fire, to this final, ethereal threshold, the edge of space, where our world's protective veil finally gives way to the great and silent ocean of the cosmos. From this final, ethereal threshold of the thermosphere, where the substance of our world fades into the profound emptiness of the cosmos, we can witness the sky's most spectacular and otherworldly performance. It is a silent symphony of light, a celestial ballet of shimmering curtains and pulsating rays that we call the aurora. This is not a light born of our world, nor is it a light from a distant star, but rather the result of a long and intricate conversation between our planet and the sun. The sun, our life-giving star, is not the placid, unchanging orb it appears to be. It is a dynamic and sometimes violent sphere of plasma, constantly boiling and churning, and from its surface it continuously releases a torrent of charged particles, mostly electrons and protons, that stream outwards in every direction. This invisible, supersonic river is known as the solar wind, and it flows through the entire solar system, a constant breath from the heart of our star, carrying with it the sun's own magnetic field. Were our planet unprotected, this constant stream of high-energy particles would be devastating, stripping away our atmosphere over millions of years and bathing the surface in lethal radiation. But the Earth is not unprotected. It has a shield, a vast and powerful defense mechanism born from the very heart of our world. Deep within the Earth's core, the motion of molten iron generates a powerful magnetic field, an invisible structure that surrounds our planet like a bubble, extending for tens of thousands of miles into space. This is the magnetosphere, and it is our first and most important line of defense against the solar wind. As the solar wind approaches the Earth, it collides with this magnetic shield, and the vast majority of its charged particles are deflected, flowing around our planet like water around a stone in a stream, continuing on their journey into the outer solar system. This constant, silent standoff is what preserves our atmosphere and makes life on Earth possible. The magnetosphere is not, however, a perfect, impenetrable sphere. Its lines of magnetic force flow from the planet's southern pole to its northern pole, creating a kind of funnel-like structure at each end. Here, at the planet's magnetic poles, the shield is weaker, dipping down to touch the upper layers of the atmosphere. And it is along these magnetic field lines that some particles from the solar wind can become trapped, caught in a magnetic current that guides them and accelerates them down into the atmosphere at incredible speeds. The aurora is the visible result of this cosmic infiltration. It is the light produced when these high-energy particles from the sun finally collide with the atoms and molecules of our own atmosphere in the thin air of the thermosphere. It is the glowing, vibrant evidence of our planet's shield at work, a battle of cosmic forces made visible as a dance of light. The beautiful and varied colours of this celestial dance are a direct translation of the chemistry of our own air. Each colour tells a story about which atmospheric gas is being energized, and at what altitude. The most common colour, a luminous and otherworldly pale green, is produced when the solar particles collide with oxygen atoms at altitudes between 60 and 150 miles. This is the signature colour of the aurora, the green glow of energized oxygen in the upper air. At even higher altitudes, above 150 miles, where the air is far thinner and oxygen is less concentrated, the collisions can produce a much rarer, all-red aurora, a deep crimson that can fill the entire sky in a soft, pulsating blush. And when the particles plunge deeper into the atmosphere, they begin to interact with the most abundant gas of all, nitrogen. Collisions with nitrogen molecules create the beautiful blues, purples, and pinks that often fringe the bottom edges of the shimmering green curtains, adding a rich complexity to the display. To watch the aurora, then, is to watch a living diagram of our atmosphere's composition, painted in light by the breath of the sun. It is a silent, luminous conversation between two worlds, a story of energy and protection, a reminder that even at the edge of the void, our planet is engaged in a constant, dynamic, and breathtakingly beautiful dance of survival. As the transient, shimmering veils of the aurora fade back into the darkness, the deeper, more permanent lights of the sky re-emerge, scattered like a fine dust of diamonds across the blackness. These are the stars, the ancient and seemingly eternal fires of the cosmos. For as long as humans have looked up into the night, we have felt a profound and innate urge to connect these scattered points of light, to draw lines between them, to find patterns and create stories in the celestial void. We call these patterns the constellations, and they are one of humanity's oldest and most enduring art forms, a grand, collaborative project of the imagination played out on the largest canvas imaginable. We see the hunter Orion with his shining belt, the graceful swan Cygnus flying down the river of the Milky Way, the Queen Cassiopeia seated on her throne. These images are so powerful and so familiar that they feel like real structures, like celestial monuments placed in the sky for us to find. But the truth is that a constellation is a beautiful and profound illusion, an accident of perspective. The stars that form these familiar shapes are not related to one another in any physical way. They are not neighbors in a cosmic city, but solitary wanderers separated by unimaginable gulfs of space. One star in a constellation might be relatively close to us, perhaps a few dozen light years away, while the star that appears right next to it in the pattern might be hundreds or even thousands of light years farther back. They only appear to form a flat, two-dimensional picture because we are viewing them from a single, specific vantage point, our tiny, moving platform of the Earth. From any other star system in the galaxy, our familiar constellations would be unrecognizable, their stars shifted into entirely new and random arrangements. The impulse to create these patterns is woven deeply into the fabric of our minds. The human brain is a relentless pattern-finding machine, constantly seeking to impose order and meaning on the chaos of sensory information it receives. For our ancient ancestors, this was a critical survival skill. Recognizing the pattern of a predator's tracks in the dirt, or the pattern of seasons in the changing landscape, was a matter of life and death. And so, when they looked up at the seemingly random scatter of the night sky, they did what humans have always done. They connected the dots. They projected their fears, their hopes, their heroes, and their gods onto the heavens, creating a celestial storybook that reflected their lives on Earth. But the constellations were more than just stories. They were essential tools. The sky was the first clock, with the rising and setting of certain star patterns marking the passage of the hours of the night. It was the first calendar, with the appearance of specific constellations in the evening sky, signaling the time to plant crops or to prepare for winter. And for mariners on the open ocean, the sky was the first and only reliable map, with the North Star, Polaris, providing a fixed point for navigation that could guide them safely home. The constellations transformed the terrifying, formless void of the night into a familiar, predictable, and useful landscape. Yet even this seemingly fixed and eternal map is slowly, imperceptibly changing. The Earth, in its long journey around the sun, wobbles on its axis like a slowly spinning top. This slow, 26,000-year cycle, known as axial precession, means that the direction the North Pole points towards in space is constantly shifting. Today, it points very close to the star Polaris, making it our steadfast North Star. But 5,000 years ago, when the pyramids were being built in Egypt, the pole star was a different, fainter star called Thuban. And 13,000 years from now, the brilliant star Vega will hold the celestial throne as the new pole star. This deep, slow rhythm means that the entire sky appears to pivot around a different point over the millennia, a silent, grand motion that reminds us that nothing in the cosmos is truly static. This sense of the constellations as a human projection is further deepened when we see how different cultures have looked at the very same stars and seen entirely different things. The 7 bright stars that many in North America call the Big Dipper are known as the Plough in Great Britain, a celestial wagon in Germany, and form part of the back and tail of the Great Bear, Ursa Major, in Greco-Roman mythology. Each culture has woven its own unique tapestry of meaning upon the same universal backdrop of stars. creating a rich and diverse heritage of celestial art. They are a mirror, reflecting not the structure of the cosmos, but the enduring creativity of the human mind, a silent testament to our timeless need to find our own story in the grand, silent story of the universe. This celestial storybook, written in the stars by the human imagination, is projected upon a backdrop of true and breathtaking physical reality. On a clear, moonless night, far from the obscuring glow of city lights, you can see a faint, luminous band stretching across the entire arc of the sky, a soft, milky cloud of ethereal light. The ancient Greeks saw it as a river of milk, the Romans as a road, and many other cultures saw it as a celestial path for gods or spirits. We call it the Milky Way, and this beautiful hazy streak of light is the answer to the question of our true place in the cosmos. For we are not merely looking at it, we are looking through it. That band of light is the collected, overlapping glow of billions upon billions of distant, unresolved stars, a vision into the dense, flattened plane of our home galaxy. We are residents of a vast, spinning island of stars, and when we look at the Milky Way, we are simply looking from our vantage point within its suburbs, gazing towards its bright and crowded downtown core. Our galaxy is a magnificent structure, a barred spiral galaxy, a great pinwheel of stars, gas, and dust that spans 100,000 light-years from one edge to the other. At its heart lies a dense, bright sphere of older, golden stars known as the central bulge. Radiating out from this core are great, sweeping spiral arms, named for the constellations they appear in from our perspective, like the Sagittarius arm and the Perseus arm. These arms are the star-forming factories of the galaxy, rich with the cold gas and dust that serve as the raw material for new generations of stars, their brilliant young blue suns illuminating them like strings of holiday lights. Our cosmic address, our home within this grand celestial city, is a quiet and relatively peaceful one. Our sun and its family of planets reside about 2/3 of the way out from the galactic center, in a smaller, partial spiral arm known as the Orion arm. This suburban location has likely been crucial for the development of life on Earth, placing us far from the intense radiation and violent gravitational forces of the galactic core, a chaotic region where stars are packed much more densely together. We are on a gentle, stable course through a calm neighborhood of the galaxy, allowing our world the long, uninterrupted peace it has needed to evolve and flourish. At the very center of this entire spinning structure, hidden from our direct view by thick clouds of interstellar dust, lies the galaxy's ultimate anchor. Here, astronomers have found a supermassive black hole, a point of immense gravitational power named Sagittarius A star. It contains the mass of 4 million suns, all compressed into an infinitesimally small point. This is not a destructive monster, tearing the galaxy apart, but rather the quiet, central heart around which everything else revolves. It is the silent, invisible hub of the great cosmic wheel, its immense gravity orchestrating the slow, graceful, and predictable dance of hundreds of billions of stars. And our solar system is a part of that dance. Just as the Earth makes its annual journey around the Sun itself, along with our entire solar system, is on its own vast and majestic orbit around the center of the Milky Way. This journey is so immense that it is almost beyond our ability to comprehend. Moving at a speed of nearly 500,000 miles per hour, it still takes us approximately 230 million years to complete a single circuit of the galaxy. This is one galactic year. The last time our solar system was in this same spot in its orbit, the first dinosaurs were just beginning to walk the Earth. All of human history, from our earliest ancestors to this very moment, has taken place in a tiny fraction of this single, grand orbit. This perspective reframes our sense of time and motion, revealing that we are all passengers on a planet, which is a passenger in a solar system, which is a passenger on a great, spiraling journey through the cosmos. Our entire world is adrift on this luminous river of light, a part of a slow, silent, and ancient celestial dance, on an island of stars in the vast, dark ocean of the universe. To be adrift on this luminous river of light, this great island of stars, invites a deeper and more fundamental question. What is the nature of the light itself? What are these individual points of fire that, when gathered in their billions, create the breathtaking spectacle of our galaxy? A star is so much more than a simple point of light in the night. It is a celestial furnace, a crucible of creation, a place where the fundamental forces of the universe are locked in a delicate and long-lived dance of perfect balance. The life of a star begins in the cold, dark, and quiet corners of the galaxy, in vast, formless clouds of gas and dust that we call nebulae. These stellar nurseries, some of the most beautiful objects in the cosmos, are the reservoirs of raw material left over from previous generations of stars. Within these immense, tranquil clouds, which are composed mostly of hydrogen, the most basic element in the universe, the patient and relentless force of gravity begins its work. Over millions of years, gravity gently coaxes the dispersed atoms of gas and dust into ever denser clumps, creating pockets of matter that slowly grow in mass and density. As these protostars contract, the pressure and temperature at their cores begin to rise, climbing higher and higher until a threshold of unimaginable heat and pressure is crossed. At this critical moment, a miracle of physics occurs. The core of the protostar becomes so hot and so dense that the individual hydrogen atoms, which have spent their existence repelling one another, are forced to overcome their natural repulsion and fuse together to form the next element, helium. This process, known as nuclear fusion, releases a tremendous amount of energy in the form of light and heat, the energy we see as starlight. This outward-pushing energy from the fusion at the star's core provides the perfect counterpressure to the inward-pulling crush of its own gravity. The star is now in a state of perfect equilibrium, a self-sustaining and controlled nuclear reaction that will burn steadily for millions, or even billions, of years. A star is born not in a fiery explosion, but in the moment it achieves this sublime balance, becoming a stable, shining beacon in the cosmos. And it is this light, this stream of photons released from the fusion at the star's heart, that carries with it the secrets of its own composition. When we pass starlight through a special instrument called a spectroscope, it splits the light into a rainbow, a spectrum of all its colors. But this spectrum is not perfectly smooth. It is crossed by a series of fine, dark lines. These lines are absorption lines, the unique chemical fingerprints of the elements present in the star's atmosphere, which absorb very specific frequencies of light. By reading these lines, astronomers can determine with incredible precision what a star is made of, its temperature, its density, and even its age, all from a faint beam of light that has traveled for trillions of miles across the void. This ability to read the substance of the stars led to one of the most profound discoveries in human history, that the elements found in distant stars are the very same elements found here on Earth, and within our own bodies. The universe is made of the same fundamental stuff everywhere. And just like living things, stars have a life cycle. They are born from nebulae. They live through a long and stable period of hydrogen burning known as the main sequence, and eventually they exhaust the fuel in their cores and they die. The manner of their death depends on their mass. Smaller stars, like our own sun, will one day swell up into red giants before gently shedding their outer layers and settling down to become a small, dense remnant called a white dwarf. The most massive stars, however, have a much more spectacular and significant fate, a fate that is directly tied to our own existence. For now, it is enough to know that each point of light you see in the night sky is not a static jewel, but a dynamic, living entity on its own epic journey through time. Each one is a tiny island of warmth and light, a balanced and beautiful furnace, patiently converting the simplest element into new ones, its glow a testament to the powerful and elegant forces that give our universe its structure, its beauty, and its light. To know that each star is a furnace, patiently forging the stuff of the universe in its fiery heart, is a profound realization, but it brings with it a deeper question. If these new and vital elements, the building blocks of worlds and of life itself, are created in the impenetrable depths of a star's core, locked away by immense gravity, how do they ever escape? How does the carbon, the oxygen, the iron, ever get out into the cosmos to participate in the grand story of creation? The answer lies in the fact that for the most massive of stars, their lives do not end with a gentle sigh, but with the most spectacular and generous act in the known universe. During its long, stable life, a massive star fuses hydrogen into helium. When the hydrogen runs low, it begins to fuse helium into carbon and oxygen. This process continues, with the star's core growing hotter and denser, creating a layered, onion-like structure where concentric shells fuse progressively heavier elements. Carbon into neon, neon into magnesium, magnesium into silicon, and finally, silicon into iron. Iron is the final ash of stellar burning. The fusion of elements up to this point has released energy, powering the star and holding it up against its own gravity. But to fuse iron requires more energy than it produces. And so, when a massive star builds up a core of iron, its furnace goes out. The outward pressure that has supported the star for millions of years vanishes in an instant, and the patient force of gravity, held at bay for so long, wins a sudden and catastrophic victory. In less than a second, the star's core collapses under its own tremendous weight, crushing itself down to an object of incredible density. The outer layers of the star, now unsupported, come crashing down towards this collapsed core at a quarter of the speed of light. They slam into the core's unyielding surface and rebound in a shockwave of unimaginable power. This rebounding shockwave, coupled with an immense blast of particles from the core, rips the star apart in a titanic explosion we call a supernova. For a few brilliant weeks, this single exploding star can outshine its entire home galaxy, releasing more energy in a few moments than our sun will in its entire 10 billion year lifetime. But this spectacular death is not an ending. It is an act of creation, a moment of cosmic seeding. In the incredible heat and pressure of the explosion itself, a flurry of nuclear reactions creates all the elements in the universe heavier than iron. Every atom of gold in the jewelry we wear, every atom of silver, platinum, copper, and uranium on our planet was forged in the fleeting, violent crucible of a supernova explosion. This act of cosmic alchemy is also an act of liberation. The supernova blasts all the elements the star has created throughout its life, and all the new ones it forged in its final moments, far out into interstellar space at immense speeds. The carbon, the oxygen, the iron, the gold, all of it is scattered and mixed into the great clouds of gas and dust that lie between the stars. This enriched material, this dust of exploded suns, then becomes the raw material for the next generation of creation. Over millions of years, gravity will once again begin to gather this enriched dust and gas together to form new stars, and, crucially, to form the planets, the moons, the asteroids, and all the other bodies that will orbit them. Our own solar system, our sun, our Earth, and every object within it is a second-generation system, built from the recycled remnants of a star or stars that lived and died long before our sun ever ignited. And this brings us to the most intimate and humbling truth of all. The calcium that gives strength to our bones, the iron that allows our blood to carry oxygen, the carbon that forms the backbone of our DNA, every single atom in your body that is not the primordial hydrogen of the Big Bang was forged in the heart of a star and scattered across the galaxy by a supernova explosion. You are not separate from the cosmos. You are a living, breathing, thinking part of it. You are, in the most literal and beautiful sense, stardust. The night sky, then, is not merely something to be observed. It is our own origin story, written in fire across the vastness of time. To understand that we are made from the dust of ancient stars, gathered together by gravity to form a world, brings a sense of profound connection to the sky. Our solar system is a tiny, stable raft, built from these recycled materials, adrift in the great river of the galaxy. And upon this raft with us are other travellers, other worlds that also move against the seemingly fixed and distant backdrop of the stars. The ancient Greeks noticed these special lights, objects that refused to stay put with the constellations, but instead wandered on their own complex paths through the night. They called them planetes, the Greek word for wanderers, and it is from this that we get our modern word, planet. For centuries, these wandering motions were a deep and perplexing mystery. A planet like Mars, for for example, will travel steadily eastward across the sky for many months, but then it will appear to slow down, stop, and begin moving backward, to the west, for a period of weeks, before once again stopping and resuming its eastward journey. This strange, looping behavior, known as apparent retrograde motion, is not a real change in the planet's path, but a beautiful illusion of perspective, a line-of-sight trick played on us by the layout of our solar system. The Earth orbits the Sun on an inner, faster track than Mars. As our planet, in its faster orbit, begins to overtake and pass Mars on the cosmic racetrack, Mars appears to move backward against the very distant, stationary stars, in the same way that a slower car on a highway seems to move backward from the perspective of the faster car as it passes. This beautiful, predictable illusion is a silent testament to the clockwork motion of our solar system, a reminder that we are on a moving world, observing other moving worlds. Not all the wanderers of our night sky are as large and distant as planets. On any clear night, if you watch the sky with patience, you will likely see a fleeting streak of light, a shooting star that flashes into existence and is gone in an instant. These are meteors, and they are the final, fiery moments of tiny wanderers, small particles of dust or rock called meteoroids that have entered our atmosphere at tremendous speeds. Most are no larger than a grain of sand, but their incredible velocity compresses and heats the air in front of them, causing that air to glow with the bright, transient light we see. On the rare occasion that a meteoroid is large enough to survive its fiery passage through the atmosphere and strike the ground, the remaining fragment is called a meteorite, a physical messenger from the wider solar system, delivered to our doorstep. Other, more spectacular wanderers visit our skies on much longer, more predictable schedules. These are the comets, often described as celestial dirty snowballs. They are ancient, primordial bodies, composed of a mixture of water, ice, frozen gases, rock, and dust, remnants from the formation of the solar system 4.5 billion years ago. Most comets spend their long lives in the deep freeze of the outer solar system, but their highly elliptical, elongated orbits can sometimes bring them plunging in towards the Sun. As a comet approaches the inner solar system, the Sun's warmth begins to vaporize its ices, creating a glowing, fuzzy cloud around its nucleus, called a coma. The pressure of the solar wind and the sunlight itself then pushes this gas and dust away from the comet, forming two beautiful, distinct tails that can stretch for millions of miles across the sky. A bright, curving dust tail and a fainter, straighter tail of ionized gas. These beautiful ghostly visitors originate from the most distant and mysterious reservoirs of our solar system. Many come from the Kuiper Belt, a vast donut-shaped ring of icy bodies that lies beyond the orbit of Neptune. Others come from the Oort cloud, a theoretical, immense spherical shell of perhaps 1 trillion comets that is thought to surround our entire solar system, extending almost a light year out into space. This great, cold cloud is the most distant and loosely held part of our solar system, a vast and silent archive of its earliest days. These wanderers, from the predictable grace of the planets, to the transient flash of a meteor, to the ethereal beauty of a visiting comet, all serve to remind us that our solar system is not a static diorama, but a dynamic, living, and ever-changing place. Each one is a piece of our shared history, a fragment of the same ancient, star-forged cloud that gave birth to our world, each following its own silent and solitary path through the deep and quiet darkness of the night. To contemplate these silent wanderers, these comets and planets and cosmic dust moving on their ancient paths, is to also contemplate the vast and silent stage upon which their journeys unfold. We call it space, the void, the seemingly infinite emptiness that separates the worlds and the stars. We think of it as an absence, a nothingness, a perfect black canvas against which the lights of the cosmos are painted. But the truth is far more strange and beautiful. The void is not empty. It is a place, a substance of its own, filled with faint echoes of the past and governed by mysterious forces that shape the entire destiny of the universe. The space between the stars is a near-perfect vacuum, a silence so profound and an emptiness so complete that it is almost beyond our earthly comprehension. Here, The density of matter drops to just a few atoms for every cubic meter, and the temperature of this background space is a mere 2.7 degrees above absolute zero, the theoretical point at which all atomic motion ceases. It is a realm of unimaginable cold and stillness, a quiet so deep that it seems to be the very definition of absence. And yet, this profound cold is not absolute zero. There is a faint, residual warmth that permeates all of existence, and within this warmth lies the first great secret of the void. This space is not entirely dark. It is filled with a faint, invisible, and perfectly uniform glow of microwave radiation that comes from every direction of the sky, with no discernible source. This is the cosmic microwave background, and it is the oldest light in the universe. It is the afterglow of creation itself, the faint, dying ember of the Big Bang. In the first moments of the universe, all of existence was an incredibly hot, dense, and opaque fog of energy and particles. As the universe expanded and cooled over hundreds of thousands of years, it finally reached a point where it became transparent, releasing all of its trapped light in a single, brilliant flash that filled the entire cosmos. That flash of primordial light is still traveling through the universe today, and after 13.8 billion years of cosmic expansion, its energetic waves have been stretched and cooled into the faint, cold microwave glow we detect today. So the void is not empty. It is haunted by the gentle ghost of its own birth, filled with the oldest story we will ever be able to read. The secrets of the void do not end with this ancient light. For decades, astronomers observed a profound mystery. Galaxies were spinning so fast that the gravity of their visible stars and gas should not be enough to hold them together. They should fly apart. Entire clusters of galaxies were bound together with a gravitational force far greater than could be accounted for by the matter we could see. The only possible conclusion was that the universe is filled with a mysterious, invisible substance that does not emit, reflect, or interact with light in any way, but which exerts a powerful gravitational pull. We call it dark matter. It is the great, unseen cosmic scaffold, an invisible web of filaments that stretches across the voids, providing the gravitational framework upon which all the luminous structures of the universe are built. The galaxies we see are like the bright, shining dewdrops that have condensed upon the vast, invisible threads of a spider's web in the morning light. The void, then, is not empty, but is structured by an immense and unseen presence that gives the cosmos its shape. And there is one final, even more profound mystery. Not only is the universe expanding, but that expansion is accelerating. The galaxies are not just moving apart, they are moving apart faster and faster every second. To achieve this, there must be a strange, repulsive force at work in the cosmos, a kind of anti-gravity that is inherent to the very fabric of space itself. We call this mysterious influence dark energy. It is thought to be a property of the vacuum, a quiet, persistent energy that resides in every cubic centimeter of so-called empty space. And unlike gravity, which pulls things together, this dark energy gently pushes everything apart. It is the silent, inexorable engine of cosmic expansion, a fundamental property of the void that is slowly and patiently stretching the universe, ensuring that its distant future will be one of ever greater emptiness and solitude. The void, then, is not an absence. It is a dynamic and vibrant stage, filled with the ancient light of creation, structured by invisible matter, and infused with an expansive energy that dictates the ultimate fate of everything. This dynamic and expanding fabric of the void is the ocean in which all the great structures of the universe are adrift. And the most beautiful of these structures are the galaxies, those colossal islands of stars, gas, and dust, each one a self-contained universe of breathtaking scale and variety. To gaze into the deep sky with a powerful telescope is to look upon a celestial garden filled with these strange and wonderful stellar blooms, each with its own unique shape, history, and character. The great astronomer Edwin Hubble was the first to create a system to classify these galactic forms, and in his work, we see the grand architectural styles of the cosmos. There are the great spiral galaxies, majestic and orderly pinwheels of light, like our own Milky Way and our nearest large neighbour, Andromeda. They have bright central cores of old stars and graceful, sweeping arms defined by the blue-white light of hot, young stars and the pinkish glow of star-forming nebulae. Then there are the elliptical galaxies, vast, serene, and featureless spheres or ovoids of light. They are cosmic relics, composed almost entirely of ancient, reddish stars, with very little gas or dust left to form new ones. They are the old, quiet cities of the universe, their star-forming days long since past. And finally, there are the irregular galaxies, the beautiful misfits of the cosmos, with no discernible shape or structure, often appearing as chaotic and clumpy collections of stars. Their forms are likely result of gravitational disturbances or ancient collisions with other galaxies. These cosmic islands are not, however, solitary castaways in the great ocean of space. Like stars, galaxies are social creatures, bound together by their mutual gravitational attraction into small groups and enormous clusters. Our own Milky Way is a member of a modest collection of about 50 galaxies, known as the Local Group, a small galactic neighborhood dominated by ourselves and the much larger Andromeda Galaxy. These groups and clusters are, in turn, gathered into even larger associations called superclusters, which are the largest known structures in the universe. These are not spherical clumps, but vast, interconnected filaments and great walls of galaxies that can stretch for hundreds of millions of light-years across the cosmos, separated by colossal, near-empty regions known appropriately as voids. The universe, on its grandest scale, resembles a great cosmic web, a delicate, foam-like structure of shining galactic threads woven around immense bubbles of darkness. This is the ultimate tapestry of existence, the largest pattern that matter has managed to form. And even within this grand structure, there is slow, inexorable, and beautiful motion. Our own Milky Way and the Andromeda Galaxy, the two titans of our local group, are currently hurtling towards each other at a speed of over 250,000 miles per hour. They are on a collision course, destined to meet and merge in about 4.5 billion years. This will not be a violent, destructive crash, for the space between the stars in each galaxy is so immense that direct stellar collisions will be exceptionally rare. Instead, the two galaxies will pass through each other like luminous ghosts, their powerful gravitational fields distorting and weaving them together over hundreds of millions of years, until they eventually settle into a single, much larger elliptical galaxy, a new creation born from the union of two ancient spirals. This future cosmic dance is a beautiful reminder that the universe is not a static picture, but a dynamic and evolving process. And all of this, the clusters, the filaments, the slow-motion collisions, is taking place upon the grand, expanding stage of the universe itself. As Edwin Hubble first discovered, when we look at the most distant galaxies, we see that they are all moving away from us, and the farther away they are, the faster they are receding. This is the evidence that the very fabric of space is stretching, carrying the great superclusters of galaxies along with it, like raisins embedded in the dough of a rising loaf of bread. From the perspective of any one raisin, all the others appear to be moving away. It is this grand, silent, and accelerating expansion, powered by the mysterious dark energy of the void, that governs the ultimate story of the cosmos. We reside on one small world, within one island of stars, that is part of a great, shining thread in a cosmic web, a web whose very fabric is slowly, beautifully, and unstoppably stretching towards infinity. To see the universe as a great, expanding tapestry, with shining threads of galaxies woven through a mysterious and dynamic void, is to arrive at the edge of our modern understanding of the cosmos. It leads us to the final and most profound question of this outward journey. What is the nature of the tapestry itself? What is the fabric of space and the current of time upon which this grand story is unfolding? The answer was offered to the world by a single mind, Albert Einstein, and it is an idea of such breathtaking elegance and power that it reshaped our entire conception of reality. His theory of general relativity revealed that space and time are not the separate, absolute, and unchanging entities we perceive them to be. They are not a static stage upon which the events of the universe perform. Instead, space and time are inextricably linked, woven together into a single, four-dimensional continuum, a dynamic and flexible fabric known as space-time. And this fabric is not passive. It is an active participant in the cosmic dance, bending, stretching, and warping in response to the presence of matter and energy. It is this revolutionary idea that gives us our deepest understanding of the force that has governed our entire journey. The force of gravity. In this new picture, gravity is not a mysterious, invisible force that reaches across empty space to pull objects towards one another. Gravity is simply the curvature of the fabric of space-time. Imagine a flat, stretched rubber sheet. This represents the fabric of space-time in a region where there is no matter. Now, place a heavy bowling ball in the center of that sheet. The sheet will stretch and sag, creating a deep depression, a curve in the fabric. This is what a massive object like our sun does to the space-time around it. It creates a deep, sloping well in the cosmic fabric. Now, if you roll a small marble past the bowling ball, it will not travel in a straight line. It will be deflected by the curve, and if its speed and angle are just right, it will fall into orbit, circling the depression in the sheet. The marble is not being pulled by the bowling ball. It is simply following the straightest possible path through a curved space. This is what our Earth and the other planets are doing. They are moving through the solar system, following the lines of curvature in space-time that have been created by the immense mass of the sun. Matter tells space-time how to curve, and that curved space-time, in turn, tells matter how to move. It is a silent, beautiful, and deeply interconnected geometry, a dance between mass and the very fabric of existence. One of the most beautiful predictions of this idea is that if space-time can be bent by mass, then everything that travels through space-time must follow these curves, including light itself. Even though light has no mass, its path will be deflected as it passes through a region of strongly curved space-time. This phenomenon, known as gravitational lensing, has been observed and confirmed countless times. When we look at a very distant galaxy that is positioned behind a much closer, more massive galaxy cluster, the light from the distant galaxy is bent and magnified by the deep gravitational well of the foreground cluster. The cluster acts like a great cosmic magnifying glass, allowing us to see objects that would otherwise be too far away and too faint to detect. We see the light of the distant galaxy smeared into arcs and multiple images, a visual and undeniable proof that space is not empty and straight, but is a curved and dynamic medium capable of bending the oldest light in the universe. And because time is woven into this same fabric, it too is affected by gravity. The deeper you are within a gravitational well, where space-time is more strongly curved, the slower the river of time itself will flow. This is known as gravitational time dilation. A clock at sea level, for example, which is deeper in the Earth's gravitational well, will tick ever so slightly more slowly than a clock on top of a high mountain. An astronaut on the International Space Station, being in a weaker gravitational field, experiences time passing just a fraction of a second faster than we do on the surface. This effect, though imperceptible in our daily lives, is real and measurable, and it reveals the most startling truth of all. Time is not a universal, absolute constant. The passage of time is a local experience, a personal journey, its pace dictated by the curvature of space-time in your immediate vicinity. The universe, then, is not a collection of separate objects sitting in an empty box. It is a single, unified, and dynamic whole, a woven fabric of space and time, whose very shape and flow is determined by the matter and energy that reside within it. A truly interconnected and holistic cosmos. This holistic and interconnected cosmos, governed by the gentle curvature of space-time, can feel impossibly vast and abstract. And yet, the most profound and immediate consequence of these grand cosmic laws is also the most intimate and familiar rhythm of our lives. It is the simple and unwavering cycle of day and night, the first and most fundamental clock for every living thing on our world. This rhythm is born from a simple motion, a celestial inheritance from the time our world was formed. As the great cloud of star-forged dust and gas that would become our solar system collapsed under its own gravity, it began to spin, and this rotation has been conserved in our planet ever since. The Earth turns on its axis, a silent and steady waltz in the darkness of space, completing one full rotation every 24 hours. This constant, reliable motion is what creates the beautiful illusion of the sun's journey across our sky. The sun does not rise or set. It is our horizon that falls away from it in the morning and rises to meet it in the evening. We are living on a great, spinning sphere, and our experience of day and night is simply our local perspective of this endless, graceful turn. It is a motion so smooth and so constant that we do not feel it, yet it governs the very structure of our existence, dividing our lives into periods of light and warmth and periods of coolness and dark. This external, planetary rhythm is so powerful and so ancient that life on Earth has not merely adapted to it, it has absorbed it, internalized it, and made it a fundamental part of its own biology. Nearly every living creature, from the simplest single-celled algae to the most complex mammals, possesses an internal, biological clock that keeps time with the planet's 24-hour rotation. This is the circadian rhythm, a name derived from the Latin for about a day. It is an ancient, genetic memory of the turning of the world, a deep, cellular resonance with the cycle of light and dark that has been passed down through billions of years of evolution. This internal clock governs the ebb and flow of our bodies, dictating when we feel awake and alert, when we feel hungry, and when we feel the gentle, insistent pull of sleep. It is the silent, invisible conductor of our physiological orchestra, ensuring that our bodies are prepared for the changing demands of the day and the restorative peace of the night. The primary conductor of this orchestra is the light itself. As the light of the morning enters our eyes, it sends a signal along the optic nerve to a tiny cluster of cells in the brain known as the suprachiasmatic nucleus. This is our body's master clock, and the morning light is its signal to synchronize, to reset its cycle for the new day. It begins to send signals that wake the body up, raising our temperature, increasing alertness, and preparing us for activity. As the day progresses and the Earth continues its slow turn, the light begins to fade. This growing darkness is the second crucial signal. In the absence of bright light, the master clock sends a new message, this time to a tiny, pinecone-shaped gland in the center of the brain called the pineal gland. This gland then begins to release a hormone called melatonin into the bloodstream. Melatonin is the chemical messenger of the night, the gentle lullaby of our own biology. It lowers our body temperature, reduces our alertness, and brings on the feeling of drowsiness that we recognize as the call to sleep. This entire intricate process is not a sign of weakness or a failure of will. It is the beautiful, intelligent machinery of the body, seeking to align itself with the fundamental rhythm of its home world. The feeling of sleepiness is the feeling of our bodies surrendering to the planet's turn, letting go of the day and preparing for the deep, restorative work that can only be done in the quiet darkness of the night. So as you feel the gentle weight of sleep begin to settle upon you, know that you are not just tired. You are participating in a dance that is as old as life itself. You are answering a call that is written not only in your own body, but in the silent, steady, and unending turning of the Earth as it moves through the gentle, curved fabric of the cosmos. To feel our own bodies align with the silent turning of the Earth is to realize that the grand rhythms of the cosmos are not distant and separate from us, but are woven into the very fabric of our being. This profound connection, this sense of the vast in the intimate, does not require us to look out into the farthest reaches of space. Sometimes, the entire majesty of the sky and the elegant laws that govern it can be found not by looking up, but by looking down into the smallest and most humble of things, like a single drop of rain. After a passing shower, when the sun emerges to illuminate the still moist air, the sky can be graced with one of its most beautiful and ephemeral creations, the rainbow. A rainbow is not a physical object, not an arc that exists in a particular location that you could ever reach or touch. It is a personal and transient optical event, a perfect alignment of the sun, your eyes, and millions of tiny, suspended water droplets. It is a vision of the sky's inner workings, a secret of the light revealed. To understand its magic, we need only follow a single ray of sunlight on its journey into a single, spherical drop of rain. As the white light, containing all the colors of the spectrum, enters the droplet, it slows down and bends, a process known as refraction. This initial bending begins to separate the colors, as the shorter, more energetic blue and violet wavelengths are bent more sharply than the longer, gentler red and orange wavelengths. The light then travels to the back of the droplet, where it reflects off the inner surface as if from a curved mirror, and begins its journey back out. As it exits the droplet, it refracts again, bending a second time and separating the colors even more distinctly. This entire process, known as dispersion, transforms a single ray of white sunlight into a miniature, fanned-out spectrum of color. Now, imagine this happening in millions upon millions of raindrops at once. Each droplet splits the sunlight into a full rainbow, but from your specific position on the ground, you will only see one particular color from any given droplet. From all the droplets that are at the precise angle of 42 degrees from the line between the sun and your eyes, you will see the red light. From all the droplets that are hanging at the slightly lower angle of 40 degrees, you will see the violet light, with all the other colors of the spectrum arranged perfectly in between. The rainbow you see is therefore a personal creation, a circle of light centered on the point directly opposite the sun, a beautiful illusion created by the collective, geometric perfection of light and water. It is the entire, grand principle of Rayleigh scattering, which paints the sky blue, and Millet scattering, which paints the sunset red, captured and reenacted in miniature within the fragile architecture of a falling drop of rain. This idea of the vast being mirrored in the small is a recurring and beautiful theme in the natural world. Look upon the surface of a perfectly still lake on a clear day, and you will see the entire, immense dome of the blue sky reflected in its surface, a perfect, shimmering duplicate of the heavens. A passing cloud will drift across the water just as it drifts across the sky. At night, the same water will hold the moon, the planets, and the distant, ancient light of the stars. The entire cosmos can be contained within the frame of a small body of water at your feet. Science has a name for this kind of repetition of patterns at different scales. Self-similarity, the principle behind the beautiful, intricate geometry of fractals. It is the idea that the same fundamental laws and patterns that shape the universe on the grandest of scales can be seen repeating themselves on smaller and smaller levels. The branching pattern of a great river system as it reaches the sea can look remarkably similar to the branching of a tree's limbs, which in turn can look like the delicate, branching veins on a single leaf. The majestic spiral of a galaxy can be echoed in the swirl of a hurricane, and even in the humble spiral of water going down a drain. It is a quiet hint that the universe is built with an elegant and efficient economy of design, using the same beautiful ideas over and over again. And so, the sky is not just above us. It is in the drop of rain, held together by the gentle, invisible force of surface tension, and in the quiet reflection on a pool of water. The universe does not only reveal its grandeur in the immensity of the night, it also whispers its secrets in the small, quiet, and beautiful details of our own world. To find the beauty of the entire sky held within a single drop of water is a quiet and peaceful revelation. And it is this same atmosphere, this same airy medium that bends and scatters light to create such delicate beauty, that also serves as our world's great and tireless guardian. The air around us is not just a canvas for the colors of the day and night. It is a multi-layered shield, a complex and intelligent system of protection that works silently and constantly to make our world a safe and gentle sanctuary for life. Its protection begins high above us, in the cold, calm realm of the stratosphere, with the silent, unseen work of the ozone layer. The sun, our life-giving star, bathes the solar system not only in the visible light that we see, but also in invisible, high-energy forms of light, including ultraviolet radiation. This energetic light, were it to reach the surface of our planet unfiltered, would be profoundly harmful to living tissues, disrupting the delicate machinery of our cells. But the ozone layer, that thin concentration of 3-atom oxygen molecules, acts as a planetary parasol. These ozone molecules are perfectly structured to absorb the most dangerous frequencies of ultraviolet light, sacrificing themselves in the process, only to be reformed in a constant, regenerative cycle. This tireless, silent act of absorption, happening miles above our heads, is what allowed life to emerge from the protection of the oceans and flourish on the land, and it is what continues to protect us every single day. The atmosphere's role as a guardian extends from this chemical shielding to a more direct physical defense. The space around our planet is not empty, but is filled with a constant stream of cosmic dust and small rocky fragments called meteoroids. Every single day, many tons of this material are pulled in by Earth's gravity, hurtling towards our world at incredible speeds. Without an atmosphere, our planet's surface would be constantly bombarded and scarred by these impacts, much like the surface of the Moon. But as these meteoroids plunge into the upper layers of our atmosphere, into the mesosphere, they collide with a rapidly thickening wall of air molecules. The friction from these high-speed collisions generates an immense amount of heat, causing these tiny projectiles to glow brightly and vaporize into nothing more than a harmless streak of light. The beautiful, fleeting spectacle of a shooting star is the visible evidence of our atmospheric shield at work, a silent and effective defense system that incinerates thousands of potential threats every single hour, ensuring that the world below remains safe and serene. And finally, the atmosphere serves as a great thermal blanket, wrapping our world in a gentle and life-sustaining embrace. This is the natural and essential process known as the greenhouse effect. The atmosphere is largely transparent to the visible light from the sun, allowing it to pass through and warm the Earth's surface. The warmed Earth then radiates this energy back outwards in the form of invisible infrared heat. Certain gases in our atmosphere, most notably water vapor and carbon dioxide, have the ability to absorb this outgoing heat, trapping it and preventing it from escaping directly into space. This trapped heat keeps our planet's average temperature warm and stable, a comfortable and life-friendly condition. Without this gentle, insulating blanket, the Earth would be a world of savage extremes, with scorching hot days followed by nights so cold that our oceans would freeze solid. The atmosphere moderates our world, smoothing out the temperature swings, and it also provides the necessary weight, the atmospheric pressure, that allows water to exist in its liquid state, forming the rivers, lakes, and oceans that are the cradle of life. The air we breathe is therefore so much more than just a gas. It is our sunscreen, our shield, our blanket, and the guarantor of the very conditions that make our world a home. It is the quiet, constant, and gentle work of the sky, holding us safely in its embrace, allowing us to rest in a world of profound and well-tended peace. To rest in the knowledge that we are held safely within this gentle atmospheric embrace is to feel a deep and instinctual sense of peace. And this feeling of being protected by the sky is only deepened when we engage in the conscious and contemplative act of looking up, of turning our attention from the immediate world around us to the vast and silent canopy above. This simple act, this upward gaze, has a profound and measurable effect on our internal state, for the sky is the most universal and accessible source of one of humanity's most powerful and transformative emotions, the feeling of awe. Awe is the experience we have when we are in the presence of something immense, something that transcends our ordinary understanding of the world and forces us to expand our mental framework to accommodate it. A magnificent sunset, a sweeping mountain vista, or the breathtaking, star-dusted veil of the night sky can all trigger this feeling. And when they do, something remarkable happens within us. Our internal chatter, the constant, self-referential monologue that occupies so much of our mental energy, begins to quiet down. Our perception of time seems to slow, and our own sense of self, with all its worries and ambitions, feels diminished, making way for a powerful feeling of connection to the world beyond our own skin. This is not merely a poetic sentiment, it is a neurological reality. Brain imaging studies have shown that the experience of awe tends to reduce activity in a part of the brain called the default mode network, a circuit that is highly active when we are engaged in self-focused thought, rumination, and worrying about the past or future. By presenting our minds with a stimulus as vast and complex as the sky, we are gently nudging our brains to let go of their obsession with the small me and to contemplate a much larger us. The sheer scale of the heavens puts our own personal problems into a new and healthier perspective, reminding us that our individual lives are part of a much grander and more ancient story. It is a natural and effortless form of meditation, a way of finding mental quiet not by closing our eyes and looking inward, but by opening them as wide as we can and looking outward. Astronauts, who have had the privilege of seeing the Earth from space, speak of a profound cognitive shift they call the overview effect, a sudden and overwhelming feeling of connection to all of humanity and a deep appreciation for the fragility and beauty of our home planet. This is perhaps the ultimate experience of awe, but we can all access a small, quiet piece of this same perspective-altering medicine simply by finding a dark place and allowing ourselves to become lost in the immensity of the night sky. This restorative power of the sky can also be understood through the lens of what psychologists call attention restoration theory. Our modern lives demand a constant state of what is known as directed attention, a focused, effortful concentration on tasks, schedules, and screens, which is mentally draining and leads to fatigue. Natural environments, however, engage our minds in a very different way through a process called soft fascination. A sky of drifting clouds, a flickering campfire, or a canopy of gently rustling leaves captures our attention effortlessly, without requiring any mental exertion. We are fascinated, but our minds are free to wander, to reflect, and to rest. The sky, in all its forms, is perhaps the ultimate object of soft fascination. It is always changing, yet always constant, offering an endless display of gentle, calming patterns that can hold our gaze and quiet our minds, allowing our directed attention capabilities to recharge and recover. So the simple act of looking up is a powerful form of mental and emotional self-care. It is an invitation to quiet the anxious self, to find a grander perspective on our lives, and to allow our tired minds to be gently restored by the soft, silent, and ever-present beauty of the endless veil above. To find this quiet sense of peace in our own minds by looking up at the sky is to arrive at the final, gentle turn in our journey. We began by looking outward, traveling from the familiar blue of our atmosphere to the farthest reaches of the cosmos, and now we have returned, bringing that vastness back into ourselves. We come to the quiet realization that the endless veil of the sky above is deeply and inextricably connected to the endless veil of consciousness within. The matter that makes up our bodies and our brains is the same star-forged matter that makes up the planets and the suns. After a journey of 13.8 billion years, a small portion of the universe's stardust has, on this small, protected world, awakened. It has arranged itself into a form so complex and so beautiful that it can not only live and breathe, but it can also wonder. It can look back up at the heavens from which it came and contemplate its own origins, piecing together the long and beautiful story of its own creation. Our consciousness is not something separate from the universe. It is a way for the universe to know itself. Our thoughts, our feelings, and our dreams are not just our own, but are a cosmic phenomenon, the universe itself, reflecting upon its own majesty. This connection is reinforced by the shared and universal nature of the sky itself. The same physical laws that govern the dance of the most distant galaxies are the ones that hold the atoms in our own bodies together. And the sky that we see is the same sky that has been the silent witness to all of human history. The same moon that shines on you tonight shone on the ancient builders of the pyramids, on the philosophers of Greece, on the sailors navigating the vast oceans, and on every human being who has ever loved, or dreamed, or grieved. The sky is the great, unifying canopy of the human experience, a constant and beautiful ceiling for our single, shared home. And its beauty lies not only in what we have come to understand about it, but also in the profound and humbling mysteries it still holds. We have given names to the great unknowns, like dark matter and dark energy, but we do not truly know what they are. The deepest questions of existence still remain, and in this mystery, there is a profound comfort. It gives us permission to let go of our need to know everything, to control everything, and to simply rest in a state of peaceful, trusting wonder at the sheer, improbable beauty of it all. And so, we bring our journey to a gentle close. We have seen that we are the children of long-dead stars, our bodies animated by the ancient, steady rhythm of our turning world. We are held and protected by a gentle, multi-layered atmosphere that paints our days blue and our evenings with fire, and we carry within us the capacity for awe, the ability to find peace in the contemplation of the vast and beautiful mystery that surrounds us. The sky without and the sky within are, in the end, reflections of one another. As you now allow yourself to drift into the final, quiet peace of the night, perhaps you can feel these two skies beginning to merge. The endless veil above, with all its silent stars and sleeping galaxies, can become the landscape for your own inner world of dreams. Thank you for joining me on this journey through the endless veil. I hope it has brought you some measure of peace and wonder. If you feel so moved, I would be deeply grateful if you would share a thought or a feeling in the comments below, and consider supporting this channel with a like and a subscription so that we may continue to take these gentle journeys together. For now, there is nothing left to do but to rest, to let go, and to trust in the quiet darkness. I wish you a deep and profoundly peaceful sleep. Good night.